Hi, this is Mr. Shinde Chitramrao, working as an assistant professor, Department of Analytical Chemistry, Sanjeevani Mahavidyalaya, Chapoli. I welcome once again all of you to our online lecture. In last lecture, we have learned about the unit first, Electro-Analytical Technique first. From this, the topic is the conductometric measurement. In this, under this topic, we have learned about the measurement of the conductance with the help of conductometer, that is nothing but conductivity cell, as well as the Watson bridge apparatus. Then today we are going to learn about the topic, that is conductometric titration, the different types of conductometric titration. So let's begin with the different methods of conductometric titrations. Let's see the apparatus for the conductometric titration. The determination of the end point of the titration by means of the conductivity measurement is known as the conductometric titration. What is conductometric titration? It is what the determination of the end point of the titration by means of the conductivity measurement is known as the conductometric titration. With the help of conductometer, we can measure the end point of the titration, that is what the equivalence point of the titration, that acid base titration or redox titration. So this type of the titration carried out, or the end point of the titration is measured by means of the instrument known as a conductometer. Such titration is known as the conductometric titration. This method is applicable to any titration, that is acid base titration, precipitation titration, oxidation reduction titration, substitution, etc. So in which there is a sharp change in the conductivity at the end point. It is not necessary to know the cell constant, since the relative values of the conductivities are sufficient to permit the locating the equivalence point. So the equivalence point is measured, there is the sharp change in the conductance or the conductance reading in the experiment. So with the help of this equivalence point, we can determine the end point. So the required apparatus for the conductometric titration is the suitable Watson bridge, resistance bridge, to measure the conductance of the titrated solution, a dipping type of the conductivity cell, a beaker to carry out the titration, a microburette to add the titrant, a magnetic or mechanical stirrer to stir the solution during the titration. These are the assemblies of the equipment, that is conductometer. What are the assemblies required? Is nothing but Watson bridge, resistance bridge to measure the conductance of the titrated solution, a dipping type of the conductivity cell, a beaker to carry out the titration, microburette to add the titrant, a magnetic or mechanical stirrer to stir the solution during the titration. For accurate work, an oil bath or the water bath may be required for the thermostating purposes. In the following figure, that give the arrangement for the conductometric titration, which includes the modified Watson bridge as well as the titration assembly. So let's see how this conductometer instrument is what appearing. So this is about the conductometric apparatus. See how this assembly is given. So here the microburette, that is from this titrant, is added. Then the resistance box as well as the Weston bridge apparatus. So the conductivity cell dipped in the titrating solution and connected to the Weston bridge as shown in the figure. A resistance box with the variable resistance, that is here, is also connected as shown. A long thin wire is also see how this the conductivity cell dipped in the titration. So see the conductivity cell here. Here is the conductivity cell. Here is the conductivity cell is there, and which is dipped in the titrating solution and connected to the Weston bridge as shown. Resistance box with the available resistance is also connected as shown. A long thin wire of a uniform cross section stretched along the meter scale is connected to the other side as shown, that is what A to B. Then to measure the conductance of the titrating solution during the titration, some known resistance R is removed from the resistance box. An alternating current is passed through the solution with the help of an induction coil, and the sliding contact D is moved on the wire AB so that the minimum or no sound is heard in the headphone. At this point, the following relationship hold: there is no conductance when the D point is at the zero resistance, so there is no sound is heard. So the resistance of the solution divided by resistance R is equal to length of BD divided by length of AD. Thus, knowing the R, AD and BD, the resistance of the solution can be calculated. So the conductivity of the solution is equal to 1 by resistance of the solution. Thus, knowing the resistance of the solution at every addition of the titrating reagent, the conductivity of the solution can be calculated. In conductometric titration, the titrant is added from the burette and the conductivity are followed during the course of the titration. So whatever we add the titrant, then record the reading. It is that is nothing but conductivity as a function of conductance. The values of the conductivities are then plotted against the volume of titrant added. Since the measured conductivity is the linear function of the concentration of the ions present, so two lines with the different slopes will be obtained and which will intersect each other at the point known as the end point or the equivalence point. The modern conductometers has a sophisticated electronic circuitry based on the Watson bridge principle and read directly the conductivity of the solution. This has made the most easily techniques of the conductometric titration. It can be measure the conductivity in which the range of the few macro moves to several hundreds millimoves, and therefore they easily accessible to such a titration. So the entire what the procedure for the measurement and the apparatus for the measurement of the conductivity, what is the requirement is the Watson bridge as well as the conductivity cell and the microburette for the adding titrant. So the conductivity cell मध्ये काय काय आहे, the conductivity cell मध्ये एक काय आहे, the conductivity cell आहे, त्याच्यामध्ये दोन इलेक्ट्रोड डीप केलेले आहेत. ज्या सोल्युशनचा आपल्याला कंडक्टन्स मेजर करायचं आणि ते कंडक्टिव्हिटी सेल कशाला कनेक्ट केलेली आहे, तर वॅटसन ब्रिज ॲपरेटसला ते कनेक्ट केलेले आहे. तर त्याच्यामध्ये वॅटसन ब्रिजमध्ये काय आहे, एक रेजिस्टन्स बॉक्स आहे ज्याचं आपण रेजिस्टन्स व्हॅरी करू शकतो आणि दुसरं त्याच्यामध्ये एक लॉंग थिन वायर आहे ए बी वायर आणि त्या वायरवर एक हेडफोन कनेक्ट केलेला आहे आणि तो हेडफोन मूव्ह होतो आणि दुसरं एक आर जे रेजिस्टन्स बॉक्स आहे त्याच्यामधून आपण काय एक रेजिस्टन्स काय करू शकतो, रिमूव्ह करू शकतो. असं एक अननोन रेजिस्टन्स आणि हेडफोन आहे जे हेडफोन त्या वायरवर मूव्ह करणार आहोत आपण. जेव्हा मूव्ह झालं कसं मूव्ह करणार आहोत, ज्या पॉईंटला आपल्याला काय मिळणार आहे तर झिरो साऊंड म्हणजे नो साऊंड हिअर करण्यात, म्हणजे तिथं नल डिफ्लेक्शन असेल. एक मॅग्नेटिक स्टरर आहे सोल्युशन स्टर करण्यासाठी आणि एक मायक्रोब्युरेट आहे सोल्युशन म्हणजे टायट्रंट त्याच्यामध्ये ॲड करण्यासाठी. मग आपण काय करणार तर आता जे मार्केटमध्ये आलेले रेजिस्टन्स बॉक्स आहेत, आपलं कंडक्टिव्हिटी सेल आहे त्याच्यामध्ये पूर्ण बिल्टअप आहे, त्याच्यामध्ये डायरेक्ट आपण काय करू शकतो कंडक्टिव्हिटी मेजर करू शकतो. आपल्याला डिजिटल कंडक्टिव्हिटी मिळते. तर आपण याच्यामध्ये एक आपण रिलेशन वापरून आपण काय करू शकतो, रेजिस्टन्स डिटरमाइन करून त्याचा कंडक्टन्स काढू शकतो. एक 0.5 ml जर आपण टायट्रंट ॲड केला त्याच्यामध्ये किती रेजिस्टन्स चेंज झाला, ते रेजिस्टन्स इज what the reciprocal of the conductivity is nothing but reciprocal of the resistance, and with the help of this we can calculate the resistance of the every addition as well as the conductance of the every addition by after plotting this graph against the conductivity and the volume of titrant added. We get the linear plot, that is what in increasing and decreasing order, two lines which bisects each other at a point, and this point is not nothing but intersect that point, and this point is nothing but what the end point of the titration. So this is about the conductometric titration and that the apparatus for the conductometric measurement. Then in next lecture we are going to learn about the different types of the conductivity conductometric titration. Let's see, I once again repeating the what is the conductometric titrations and what is the conductivity. Conductometric titration. What is the conductometric titration? Conductometric titration is nothing but the titration which is used to measure the conductivity of the solution by using the what? By using the apparatus conductometer. The determination of the endpoint of the titration by means of the conductivity measurement is known as the conductometric titration, and with the help of the apparatus we can measure the conductivity is nothing but the conductometer. That what type of the conductometric titrations included, or in which we can measure the endpoint of the given titration. The such type of titrations are the what? Acid base titration, precipitation titration, oxidation reduction titration, substitution titration. And what is the requirement of the measurement of the titration? What is the apparatus? That is what the suitable Western base resistance bridge, then conductometric cell, as well as conductivity cell which is deep in the beaker, and to carry out the titration, microburette and the magnetic stirrer or the mechanical stirrer for the stirring solution. So such type of the, or we can use the water bath for the stable temperature. So such type of the apparatus which is used to measure the conductivity of the solution, and every addition of the reagent. So this is about the apparatus for the conductometric titration. In next lecture we will see about the different types of conductometric titration, that is nothing but acid base titration, precipitation titration, substitution titration, as well as the oxidation reduction titration. So thank you. If you have any queries regarding this topic, that is the apparatus for the conductometric titration, what is conductometric titration, please put your question in the YouTube comment box. I will try to answer your question. Please keep watching the videos. Thank you. Thanks a lot. Have a nice day.